This is CLO4.3 and 4.4 combined. It's about computing the compound amount and interest, and also finding the present value if given the future value using the compound interest formula. Okay, in the previous video, I gave you three equations that were simple interest equations. Unfortunately, there are a lot of examples where we cannot use those simple equations. Examples that mention compound interest, there is a much uglier equation we must use. So anytime you see the word compound in the problem, you have to use this uglier equation. You cannot use the simple interest equation. And what is compound interest? You can think of it as interest on top of interest. So what the banks do is they will calculate the interest you owe, and then they will add that interest back onto the principal, and when they calculate the interest next time, they're calculating the interest on top of the interest. It's a way for the lender to make more money on interest payments. So it's a little more complicated, and we have this complicated formula. Whenever you see the word compound in a word problem, you're going to know we need to use this complicated formula. And in addition to that, the question will be, what is M? As you see in that equation, there is a letter M. And the way you can know what is M, you'll see it in the question itself. If the question says compounded annually, that means that one time per year, the bank is putting the interest back on the principal to recalculate the interest next time. If they say semi-annually, that means that twice a year, M equals 2, the bank is taking the interest and putting it back on the principal to calculate the next interest payment. Quarterly means the bank is doing that 4 times per year. If they say monthly, the bank is doing it 12 times per year. And if they say compounded daily, that means the bank is doing that 365 times in a year. And the idea is the more often that they take the interest and recalculate and put it on the principal, the higher the overall interest is going to be at the end of the year. So whenever we have a compound question, we use this complicated formula. If they ask for the interest that you paid, you can then, as a second step, subtract the future value and the present value, and you will get the interest amount. So let's do some examples and see how this works. So like usual, we'll just start reading the accumulated value. We need to find the accumulated value. So we need to find S, the future value, and find the compound interest earned. So we have to find I. When investing $3,000, that's your principal, that's your starting amount, at 7.5%. So the rate as a decimal is 0.075. Compounded monthly. Whenever you see the word compounded, you know two things. You know you're going to use this uglier equation. We cannot use the simple interest equations. And in addition to that, we have this new letter, M. When we see the word compounded, our first question should be, what is M? Well, it says compounded monthly, so M is 12. For 3 years, T equals 3. Now all we must do, plug and chug, put in 3,001 plus 0.075 divided by 12, raised to the power 12 times 3. And we will get as our answer, my calculator says, 3754.338. Now for money, we want 2 decimal places. So 0.338, I'll say 0.34. And the units in this case are dollars. And now it asks, well, what's the compound interest earned? So that's the I. I equals the future value minus the present value. So we will plug those numbers in, 3754.34 minus the starting amount of 3,000, and we get that the interest earned was $754.34. Okay, let's try another one. think they're all worded the same. So find the accumulated value S and the compound interest earned I. When investing 1,000, it doesn't say what the units are, so let's assume these are dirhams, 1,000 dirhams. The rate is 6.9%, 0.069, compounded semi-annually. Okay, I see the word compounded, so I know the equation will be the uglier compound interest equation. And then I have to ask myself, well, what is M? M, compounded semi-annually, that means M is twice per year, and T is 3 years. So we plug everything in this case, 1,000, 1 plus 0.069 divided by 2 raised to the power 2 times 3. I plug this all into my calculator and I get 1225. Now my calculator says 0.696, but for money we need 2 decimal places, so that will round up to 0.70. And in this case I said it was dirhams. And again, they ask us, well, what was the interest earned? That's just the future value minus the starting value, the present value. And so we will plug that in. The future value, we calculated 1225.70 minus the starting value of 1,000. The interest earned was 225.70 dirhams. So again, it's quite easy if you just plug and chug the right numbers in the right place. One last question. Find the accumulated value again. So find the S, find the future value, and the compound interest earned I. When investing $40,000, that's the starting amount. P is $40,000. 3.9% is the R, 0.039, compounded quarterly. So again, I see the word compound. I know it's the complicated equation that has a lot of parts to it, and I have to ask myself, what is M? Well, if they say quarterly, that means 4 times per year. M is 4, and T again is 3 years. Okay, so we will plug everything in, and we say 40,000, 1 plus 0.039 divided by 4, all raised to the power 4 times 3. We will get a future value of, according to my calculator, I got 44,939.303. So rounding to 2 decimal places, 0.30, and in this case it's dollars. And lastly, to answer the last part of the question, what was the interest earned? You just do S minus P. And so we will plug in 44,939.30 minus the original amount of 40,000, and we get that the interest earned was 4,939.30. Okay, simple enough. Okay, these next 2 questions are a little bit more complicated. Let's just start reading and find out why. It says, how much was originally invested? So in this case, we're not sure about P. We don't know how much money was originally put in the bank, but they're saying the accumulated value is 32,000. So the future value is 32,000. And it said it was a period of 5 years, T equals 5. The rate is 7% and compounded annually. That means M equals 1 time per year. Now remember, when we see the word compound, we know we've got this equation that is appropriate, the more complicated equation. But the issue is I know what S equals, I don't know what P equals. So it will be easier for us if we could rearrange this equation and have P equals. And how we will do that, we'll take the S and we will divide this entire bracket, we will divide it under the S. So we get P equals S divided by 1 plus R over M raised to the MT. So this is the easiest equation to use when they give you the future value and you want to go backwards and find out what was the present value. So we know the present value is always smaller than the future value. So we'll be looking for an answer that is smaller than 32,000. Let's plug everything in and see what we get. So we have 32,000 divided by 1 plus 0.07 over 1 raised to the power 1 times 5. We'll plug it into our calculator and see what we get. And we get a present value, a starting investment amount of 22,815. My calculator says 0.557, so I'll say 0.56, rounding to 2 decimal places. And this is dirhams. All right, let's do one more similar question. How much was originally invested? Again, we don't know the original amount, but they're saying the accumulated value is 45,000. So the original investment will be something less than 45,000. They said it was 4 years, so T equals 4. The interest rate is 9.7%, 0.097. Compounded monthly, so M equals 12. So again, I'm going to use this equation for P, and I'll say P equals 45,000 divided by 1 plus 0.097 over 12 raised to the power 12 times 4. We'll plug that in our calculator and see what we get. And we get a value of 30,576.21. And the units, again, in this case, are dirhams. Okay, this last question is a very popular question on exams because it requires you to do a little bit more than just calculate. You have to do some thinking and analyzing. Basically, the idea is May is deciding where to invest 35,000. So we know the starting amount will be 35,000, and she'll leave it in the bank for 10 years. So the time is 10 years. But she's choosing between 3 different banks, Bank A, Bank B, and Bank C. And each bank is giving a different offer. So she's going to have to do some calculations and decide which bank will be the best offer for her. So this is a very practical question you might face in real life, choosing the best offer. And by the way, the best offer might be different dependent upon whether you are borrowing money or whether you are investing money, putting in money in the bank. In this case, we're investing money. So the best offer will be the one that gives us the biggest future value. Okay, we want to put our money in a bank that will give us the absolute most money we can at the end. That would be the best offer in this case. Just as a side note, if we were borrowing money, we would want at the end to pay back the smallest amount of money. So we would want the smallest S, but that's not this. In this case, we are putting our money in a bank. So we need to decide which one's going to give us the most money at the end. Well, first we'll do Bank A. In Bank A, the rate is 0.035, and it is simple interest. So simple interest, we'll just use the simple equation, P 1 plus RT. So we plug in S equals 35,000. 1 plus 0.035 times 10 years, and we'll get that the future value, if we choose Bank A, will be $47,250. Okay, that's for Bank A. Now let's look at Bank B. Here are the terms of Bank B. The rate is 0.034, but it's compounded annually. So we're going to have to use the uglier compound equation, P 1 plus R over M raised to the power M times T. We'll plug in the starting amount of 35,000, 1 plus 0.034 divided by 1 times, raised to the power 1 times 10 years, and we will end up that the future value of Bank B is $48,896.20. $0.01. Okay, last bank is Bank C, and this says the rate is 0.033, 3.3%, but it's compounded monthly. So again, we'll use the compounding equation, which is slightly more complicated than the simple equation. And we will plug in all the data. We put in our initial investment, $35,000, 1 plus 0.033, divided by 12, raised to the power 12 times 10. We plug all of that into our, sorry, this is bothering me because it's not, you can't read it, 12 times 10, looks better. We plug it into our calculator and we get $48,661.84. Okay, so the question is which is the best offer? Which bank would give us the most amount of money at the end of 10 years? This one is the best offer. It gives us the biggest future value. By the way, if we were borrowing money, we would choose Bank A because we would want the smallest amount of money that we have to repay at the end. Okay, that's the lesson. Good luck, everyone.